E-stat residual. Let me just check this. So residuals, I'm going to come back to that one. So okay. All right, so let me show you what I just done, and then E-stat residuals. Sorry. Okay. All right, good. All right, so let me show you what I've run here. So actually, I'll use my previous command. So I'm so SEM behavior is this large enough to actually see? I'll make it. All right, so the data that we brought in is 17 questions from Likert type scale questions from a survey. And these are questions about students. I think there's approximately a little over 2,000 students that data was collected from. And the types of questions are students engaged in class, students not engaged in class, students outgoing, different types of behavioral things with a little more focus toward interactions with the teachers and interactions with the students. So these particular 5 items, 1, 2, and 3, 10, and 14, are theoretically supposed to be this measure of outgoingness. Okay? So what I've typed in, this is all I need for a CFA analysis, is SEM space open parenthesis outgoing, and then it's a space minus greater than sign space, and there's a little arrow. This is saying outgoing is being assigned to these 5 variables. I could have typed Q1 space Q2 space Q3, but State is smart enough to know when you put a hyphen, it's going to look for everything between those numbers. So I did Q1 through Q3, Q10, and Q14. And when you run this, so fingers crossed, you hit enter, and it runs. Takes a little while. And when it stops for more, you should just be able to hit the space, and it will give you the rest of the information, and then you can go back and scroll up through it. I don't know why it still uses that feature, because it's not like anyone doesn't have scrollable user interface screens. All right. So let me walk you through the basic output that it gives here, and then I'm going to show you where we go to get some of the additional information, and we'll do a couple really quick calculations here to see that it's actually true. So the first thing it gives in the output is what the endogenous variables are. And the measurement variables, endogenous can be measurement or latent variables. Most measurement variables are endogenous because the latent variable is influencing those. So the measurement variable is Q1 through Q14, the 5 listed there. Then it says what the exogenous variables are. In this case, it's only outgoing. So we really have a very basic congeneric factor model, one factor, where we have the 5 items loading onto the same factor. Now, so this gives us the target model. This is the estimation. It actually thinks it found a solution relatively quickly. And total of observations of 2,062. Estimation method is ML. The log likelihood value, which is what we'll talk about next week or the week after if we take the next week off. And then it gives all of the information that we need. So it gives the coefficient and other information for the model. So coefficient, the standard error of that coefficient, the z-score, the likelihood that it's different from 0, that probability and a confidence interval for those values. Then it actually estimates the variance for each of the error terms, and it estimates the variance for our latent variable, because if we notice up here, what it did is it actually constrained the first path to a 1. And then the LR test of model versus saturated is a measure that we're going to see is actually a way to determine if the model fits or not.
Can you say that last part again?
The chi-square here?
Yeah.
We'll use this to see if the model fits. So this last, it's the very last line. It says chi-squared, parenthesis 5 equals, and it gives the value, and then it will give a probability for that.
What is the saturated?
Saturated is the full model where it says, I'm just going to estimate what every correlation is straight out. So there's two important models that we'll think about. Those are the independence model, where we assume that every value has a variance that we've measured, and there's no correlation between them whatsoever, which pretty much couldn't be more wrong if we tried. So that's what we call the independence model, and that's so far at the extreme. The other extreme is then when we say, well, I'm just going to use every value. I'm going to let the estimate for variable 1 and variable 2 be what that value was in the matrix. In other words, you literally just take all of your values from your sample and just assign them to the values in the matrix. So we call the saturated model. So the key is you're essentially saying my matrix model and my measurement, my population model and my sample, my population matrix and my sample matrix are essentially the same thing. That's what we say when we mean this saturated model. Haven't talked too much about those yet because we haven't talked about fit measures, which is the very next topic. So those questions are really important because that's exactly where we're going next on the path.
So linear regression test of model versus saturation.
LR test is it's not linear regression. It's actually what does LR stand for?
Likelihood ratio.
Likelihood ratio. Thank you.
Okay.
Thank you. Because I was thinking, my brain couldn't get out of regression after you said it. I was like, I don't think that's right. All right, so what I want to show you now is, let me jump from this to the standardized really quickly. So I'm going to do SEM, comma, standardized. And I think if let me check. I'm pretty sure I need to type, I needed to type the comma for it. It's just taking the output and saying, oh, let me reshape it just a little bit. So I'm going to write on the board what this essentially is telling us. This is saying there's some construct pointing to our 5 variables, and the correlations are about 0.85, 0.80, 0.86, and if I hit space, it should show me a few more, 0.92, and 0.87. Again, it's 1, 2, 3, 10, and 14 are actually our measurements. And this is the idea of outgoingness. Now, everything else pretty much is going to be the same. Now, the key is, with this information, what this is actually saying is as standardized, this says that my correlation here is 1. Correlation, the variance for my variable is 1. And there's still an error on each of these, but the error is such that the variance for each of my values is 1. So this number I don't care about because it technically has to be 1 minus 0.85 squared square rooted. Okay? And the reason I know that is this number squared and this number squared added together should equal the variance, which has been standardized to be 1. Okay? Well, technically this is actually the standard deviation.
Oh, that's why all of the OIM standard errors are no. Just there, so close to 0.
These values are actually these ones?
No, sorry. I mean,
these standard errors,
yeah.
those are,
Yeah,
they're going to be, this is relatively a good fitting model, so those are going to turn out to be pretty good. All right, now, this doesn't seem like a lot of information, but with this information, I can actually now begin to construct or reconstruct the correlation matrix for my variables. So if we have 1, 2, 3, 10, and 14, well, I know it's got to be 1s down the diagonals. But if I want to determine what's the correlation between 1 and 2, there's only one path to get there. 0.85 times 0.80. That's really the only way I can get from 1 to 2. So my correlation here should be 0.80 times 0.85. Correlation between 1 and 3 would be 0.85 and 0.86. I'll do one more. I'll do 10 and 14. 10 and 14 should be 0.92 and 0.87. And you see now that with this information, I should be able to go in and fill in all of the numbers in this matrix. And remember, I don't need to worry about the top, it's the same. This is the model estimate. So if I'm being really precise, this is sigma, theta. I've estimated the thetas. And the only thing that's different is it's technically not sigma. That's the covariance matrix. So I just put a star to remind myself it's the correlation matrix. The key is this. I needed my model data, my model information, more specifically the parameters. I needed the parameters to be able to fill in this matrix. So with the information, I can fill in the matrix. And so now what we're going to do, E-stat residuals. I typed E-stat space residuals. Now, I don't think this is going to work. Let me give it a try. Residuals, comma, standardized. I was afraid of that. Okay. So I'm going to go back and type E-stat. I'll come back and talk about what's been reported here. Residuals. All right, so this gives me the residuals for, unfortunately, this gives me the residuals for the covariance matrix. All right, now, what does that mean? So these are the residuals for the covariance matrix. Well, what I did here was I was taking advantage of the fact that I used the correlation matrix to make it easier so I don't have to write it out in its goriness. But if I had used unstandardized values, I could actually construct the matrix using all the values, not just the loadings, but all the estimated correlation values. I could reconstruct the correlation matrix or the covariance matrix, where the covariance includes the variance for each of my variables. I'm going to use a shorthand for this. I'm going to call this sigma hat. Well, now this technically means this is an estimate. I know what I actually have. I want S to be equal to sigma hat. So what I'm going to do is I'm going to look at the residual matrix, which is sigma hat, my estimated values, minus my actual observed values.